All right, let's start. I hope you all enjoy the Thanksgiving holiday. And then the good thing is we will have no more quiz, no more new assignments. So all the assignments and out was the like the are all the things. And then don't forget to finish NSA Code Breaker Challenge. And then that will close at noon of the December 9th. So if you are waiting until the due date comes, please finish it before there are two different due dates. So the due dates for the NSA Code Breaker is at noon. And then at the midnight, there will be the due date for the other assignments. So please don't forget about that. And then we will learn about the software attacks because we covered the software vulnerabilities in last week. And then we will learn more about what attackers can do. And then how the software attack community works for now. So the topics for today, we will learn a little about some of the compiler options and tools that we can use to detect or prevent some potential software vulnerabilities. So it's something like you write whatever code, but we are human, so we are imperfect. So sometimes we wrote some of the bad code, and then our compilers has some of the tools that automatically detect those not that secure code and then give warning to that. And also it has a dynamic measure to monitor the memory if any kind of the buffer overflow or use of the free, that kind of the vulnerability happens. We will learn about that. And then after that, we learned about the CVE. So whenever the white hat hacker finds a vulnerability, the good model is they report to the vendor, and then vendor fix it, release the patch, and then they announce the vulnerability description as a CVE to let everybody know about there was a vulnerability, so here's a patch, so update. Yeah, something like that. And then, so we will learn more about what other ways about having the disclosure of the vulnerability responsibly, or how can we interact with the vendors or others to securely report vulnerability to them. And then I will cover a little bit about the cyber weapons and then some attack scenarios. And then on Thursday, as a final lecture, we will learn more about the malware and Stuxnet to learn about what are the real threats out there. And then let's do a little recap about what we learned about the software vulnerabilities. So softwares are complex. So modern softwares, they do have several millions of lines of the code. And then they are hard to protect, not because they are complex, but because underlying library codes are also complex. So what it means is that suppose you just wrote the 10 lines of code for resizing a JPEG image. But to do that, what you need to write is just the 10 lines of the code. You will use the libjpeg to load the image and then just resize it and then run it. But what you are actually running is not your code, the code written for libjpeg. Somebody else have written that code. And then if there's a vulnerability, then your program will hit that too. Yeah. So that there is a software dependency. So not just because the modern software itself is complex, because their dependencies are enormous. So there are a lot of chance that if anyone makes a mistake, then we are all fried. And then if the mistake happens, some of the benign way to make it the benign way that a benign outcome could be just a crash. So in that case, we can just restart computer and then that's it. So we might lose some of the data that was not stored during the crash, but it's not about the game over. But in case of the hackers analyze the code and then intentionally control the error to exploit the vulnerability, then we learned that we can read the flag and then we can run another function in the buffer overflow example. So something like that, the hackers can change the execution of the program. That means they can change the behavior of the program. So even if the program is just a web server or something, if they do have a buffer overflow vulnerability, we can make it as running some of the games on it. Yeah, that's actually possible. So the worst case result could be something like this, but that kind of thing happens a lot in these days. And then we've learned about the 4 different classes of the vulnerabilities. So we just schemed it. Yeah. So the buffer overflow vulnerability is something like in C and C++. They are not that memory safe language. So what that means is like that whenever we access the memory, it does not check whether we can access that or not. So because C languages, C and C++ do not have a check like that. So even if you assert the buffer has the size 100 bytes, this string copy all the data. If there's a no null character, it will copy all the data from the buffer. And then if the data variable store more than 100 characters, then that's where the buffer overflow happens. And then because we store some of the control data, for example, return address, and also we store another local variables in the program stack, and overflowing the buffer let attackers change those variables. So that's why the attackers can take control over the program. And then I briefly introduced about the printf. And then the format string part of the printf need to be some constant or never be controlled by the attackers. Yeah. But there are cases that we are programmatically generate these kind of the format strings using a lot of sprintf to build a string and then finally use the printf to do something. But if any of the attackers input can get in here, then they can manipulate and then leak some of the stack variables. Because printf, what it does is like it does not know how many arguments are there. So if there is a % something, they just go up the stack and then print it. So if you have a lot of %p on the printf, then you will eventually print out the return address or save the EBP, so you can get all these kind of the values. But if you're interested in more about learning these kind of vulnerabilities, please take the class called the Cyber Attacks and Defense offered in next term. And then right now it is fully enrolled, but I will change the number of enrollments to change the undergrad limit to 50 or something. So yeah, there will be a lot of positions. And then the use of the free vulnerability is something like you create one of the object and then freed it or deleted it. But if we use the deleted object, then that's the case of the use of the free. And then the case of the logic bug was like having 2 go to fail, not braced with the if clause. So like this is the definite mistake, and then that changes the entire flow of the program. So yeah. So there are several cases of the vulnerabilities. And then so the important thing is that the software is complex. And then there are several cases, so many cases that you can create the vulnerability. And then as a well-trained security researcher, it could be better to generate the more secure code, but not for the general developers. And then, so one way to reduce the risk of the having software vulnerability is train them and then making them write the secure code. But it's hard. But the easier way, if possible, is try to build the tools for like the automatically checking if there's a buffer overflow vulnerability or if there's any kind of case that the printf can get user input, network input, those kind of thing. Yeah. And then we actually do that. So one of the practice to reduce the risk of having the vulnerability is that the compiler, so the compiler designers implemented some of the routines. So basically think about what compiler does. So the modern compiler, how it works is like as a front end and then back end. And then front end means like the C, C++, Java, Go, those kind of a language. And then compiler translates this kind of the specific language into some of the meta language. So we call it as an intermediate language, so abbreviated as IL. Yeah. or IR. Yeah. So, and then like that's the meta language that we can see. So even if you compile, you write the code in C, C++, Java, or Go, then we can all compile in the same type of language. And then in this language, we do all the optimizations and also do the security checks. So that's where the compiler designers inserts this kind of the security checks. And let's take a look at the example on the left side. So this is a very simple code. And then there's a buffer size 10. And then you can immediately identify that this fgets will cause the buffer overflow vulnerability because it will fill up to 512 bytes for the buffer size 10. So that's the one vulnerability. And then the other vulnerability is like the buffer will take the user input using fgets from the standard in, but that will directly go to the printf. So there is a chance of like the attackers can launch format string attack. And then I just wrote the code and then compile with the default compiler. So I wrote it as a GCC, but this is an Apple machine. So internally it's a Clang. Yeah. So Clang is like the Apple's version of the compiler. So it's more likely open source. So there are two popular compilers. One is GCC, GNU Compiler Collection, and the other is like a so-called LLVM, so low-level virtual machine. And then LLVM-based compiler is so-called Clang, and then GNU-based compiler is GCC. And then both the GCC and then Clang compiler support a similar feature, so that you will have a different error message if you run the same command on the Linux. But if you run the same command on the Mac, because they will use the default, by default, the Clang, you will see the same message. And then let's take a look at what kind of the warning message comes out from the compiler. So compilers, when compiling the code, it will lift this kind of code into the intermediate language and then try to analyze that to see if any kind of the first argument of the printf is like a non-const string, and then that could come from like the outside input. And then they are actually saying format string is not a string literal. And then, so it says no format arguments, but so that could be benign, but the first one, so format is not the string literal. So it's a dynamic buffer. So like there is a chance that the attacker's input comes in. So they are giving that warning. And then second warning is about the fgets, writing 512 bytes, region of size 10. And then they know that the buffer overflow happens at there. So, and then like I believe like I mentioned it before. So like I know that the many people just ignore compiler warnings and then take care about the errors, because with errors, you cannot have the binary program. Yeah. But even with the warnings, you need to know that your program somewhat works, but it's not complete. Could have some of the corner cases or security vulnerabilities. So please take a look at the compiler warnings thoroughly, and then try to remove all of them if you want to make the secure and robust program. And this is a default feature. And then there is some additional feature in the compiler, and then you can add that as an option when you run compilation. So for example, one of the compiler option is so-called fortify source. And then, so -d here is like it has the same effect of sharp define _ fortify source 2. So the -d something is like has the same effect of like writing the sharp define some of the name of the variable and the value in the code. So it's actually defining the fortify source as a level 2. And then level 0 means to protect nothing. Level 1 is like run a compiler check for the protection. And then level 2 is run a compiler check for the protection, and then also do the runtime check. And then, so what runtime check means is that like it's something like, even if you write the printf or string copy or that kind of function, compiler will insert more code around there to check if like running up the string copy will overflow the buffer. so that they can dynamically check those kind of thing at runtime by inserting code. So even if you have like 10 lines of code, when we do compilation, compiler will insert a lot of code to check if your current execution is not violating the security things in the system. So I compile the same program. So it has like the fgets, and then the buffer overflow vulnerability, and then the, what is that? The format string attack. So on the left side, I compiled it without Fortify source level 2. So Fortify source level 0. That means no protection at all. And then if I fill the characters more than 10 character, it will overflow buffer at here. So it will be result in segmentation fault, just crash. And then if you carefully design your payload, then you can change the return address, and then you can run any other program. And then if I run /a and then put %n. So the %n, what this means is that like it will take the first argument, and then it will write the number of the printed characters. So that right now we just make the printf call. So this printf call has not printed any characters. So what it will do is like it will take the first argument as an address and then put 0 inside that address. And then we didn't put any kind of the legitimate pointer address for the second argument. So like it will just generate the segmentation fault. So the left side, without protection, you will get segmentation fault. And then there is a chance that attackers can control it to exploit the vulnerability. But on the right side, I inserted the Fortify source level 2. And then if I insert long characters, and then at runtime, it will examine the length of the second argument. And then it knows that the length of the first argument by the compiler. Because in the code, it is written as 10, right? So at runtime, it will check whether the current copy of the string overflows the buffer or not. If it is, it will kill the program. So it says terminated and then detected, aborted. So it's not like just a crash. So there is no chance the attacker can control over those kind of the buffer overflow. And then for the format string case, I just type %n, then it says %n in writable segment detected. So what Fortify source 2 does is it actually disables %n. Yeah. So that we cannot use that. Whenever we use a %n, then it will kill the program. Yeah. That's how like this compiler option can prevent the buffer overflow or format string attack happening, even if your program has a vulnerability. So it's not about we are removing the vulnerability. So it's something like your vulnerable code is there, and then before running your vulnerable code, we are running a lot of checks to check if we are securely run this code or not. So it's more likely, even if your program has a vulnerability, we can instrument the program to have a security check before running all of your code to make it secure. And then another option to introduce is so-called address sanitizer. Yeah. So for this one, this is developed in 2010-ish, I believe. Yeah. And then there's a GitHub project, and then you can read about the techniques inside of here. And then what it does is so I told you that C and C++ does not have any kind of check when we access the memory. And then what they are doing is that we need to use the address sanitizer. We need to recompile the entire program. And then the compiler will insert all the code to check if any kind of memory access is legitimate or not. So every time we access an array, so the previous case, the Fortify source, so it runs the security check before running fgets. That's it. But in address sanitizer, it runs fgets. But what it does is like the inside of fgets, it will access the memory. There's a buffer. It will fill byte by byte. And then address sanitizer actually insert the code to check know the end of the buffer. And then if it hits on writing the outside of the buffer, then it can detect that and then stop the program, just making a crash to making it never controlled by the attacker. So suppose we have this problem of this program, and then it has two vulnerabilities. So the first thing is like that I allocate the buffer as 10 bytes, but I put the 512 bytes up to 512 bytes with the fgets. There's a heap buffer overflow. And then in this printf, there's no format string attack, but I free the buffer and then try to print it. So actually, I did use after free. Yeah. Then let's check how each of the vulnerability can be caught by the address sanitizer. So the program execution is something like, if I put more than 10 bytes, it will stop at fgets because there's a buffer overflow vulnerability. But if I put less than 10 bytes, fgets is legitimate, it'll pass, and then it will trigger the use after free vulnerability. So let's take a look at the triggering the heap overflow first. So that I put a lot of characters like this. Then anything below this kind of the equal sign line is that printed by the address sanitizer. And then we can see that. So some of the address is located 0 bytes to the right of the 10 byte region or something. So this says there's a 10 byte region, and then there's a no allocated memory. So the accessing that is like the violation. And then it also let us know about which line was problematic. Main A.C line 6. 1, 2, 3, 4, 5, 6. No, I believe like I erased one of the line over here. So this one generated, yeah. No, allocated by thread T0. So allocated by line 6 at here, and then line 7 triggered heap of overflow vulnerability. And then how address sanitizer works is that, so technically, so suppose we have a program area, and then we actually split the virtual memory address into 2. So there's a regular program area, and then we could have the shadow area as a secret. And then whenever we allocate the memory here, then we allocate some of the shadow data here. So for example, whenever we run malloc 10 bytes, then we record this memory object for this pointer has a length 10. So that's how the address sanitizer knows all the length, and then they can check at runtime. And then the second thing is about like when I type A, then it will pass fgets and then stop at free. And then what it says is like a heap use after free on address this one, and then allocated by main that freed by line 8, then allocated by line 6. They all know that. And then so this is actually the violated byte, and then FD means that the freed heap region. So the address sanitizer knows that our program tried to touch the memory address that was already freed, so that they will prohibit the program execution goes forward. Any questions about the compiler options? So the good practice is that use the D45 source, and then also enable the treat warning as an error. Those kind of thing is a good practice for like the deployment. And the address sanitizer, in contrast, because it inserts a lot of the code in the runtime, so their performance overhead is around the 200%. So your program can be 2 or 3 times get slower if you insert the address sanitizer to your program. So address sanitizer is not about the deployment purpose. So if you want to release your software and sell it, you don't include the address sanitizer because it's 3 times slower. But instead of doing that, what you can do is like you will have your own test running. And then like for that application, you can add the address sanitizer and then run with a lot of test cases. And then if any kind of thing hits this kind of thing, then that's the bug, you need to fix it. That's how we can use like various compiler options to protect our programs. And then next is about the CVE. So we learned about the CVE, and then that's the database about the, oh, there's this kind of the vulnerability, so fix it. Yeah. So this is something like a public database about like what kind of attacks has happened in recently, and then based on that report, we can, as a system operators, we can decide what kind of the softwares to update, or we can also examine what kind of our products are affected. Yeah, something like that. And then each of the CVE record has a not that detailed, but enough information to assess about the severity of the severity of these vulnerability, because it says buffer overflow, and then like what kind of modules, and then what kind of versions are affected. So the CVEs can be reported and generated by the developers. So while they are developing, they figured out mistake using like this kind of the address sanitizer. And then if they think that there's a chance that attackers can exploit this, then they issue CVE and announce that as like announce it. And then the implication of the releasing the CVE is that all the system operators, so it's something like telling all the system operators about update their system if they are running affected version. And then white hat hackers. So they are not developers, but that they can do source code auditing or do reverse engineering, and then applying fuzzing, symbol execution. And then there are a lot of testing techniques. And then if they could find the vulnerability, then write an exploit. Then instead of using that for their own purpose, they can report to the vendors, and then vendor will fix that. And then after fixing that, they will announce the CVE to let other users update that. So I want to introduce some of the good model of the reporting the vulnerability, because the vulnerability disclosure is important, because if some of the systems are remaining unpatched, even if they are having the vulnerabilities, then there could be a chance that I'm not the only one who knows about the vulnerability. There could be some other guy already hacked that machine and then still use that. Yeah. And then if I don't report them, then they will just remaining as insecure. But if I report that, then vendors will fix that, so they are no longer getting that kind of threats. So vulnerability disclosure is important, but if you disclose it arbitrarily, for example, just upload in GitHub and then shit on Twitter, I found this vulnerability great, then there's a chance that the hackers just steal it and use it. So one of the rule, again, not the strict law, but one of the rule is that the white hat hackers do not disclose details of the vulnerability until the vendors release the patch. Because if there's no patch, it's something like releasing the COVID-like virus. There's no remedy, and then releasing to public, something like that. So because that's too dangerous, so vulnerability disclosure is important. And then let me demonstrate, let me introduce one of the good model of the reporting the vulnerability to the vendors. So suppose a white hat hackers found a security vulnerability, and then they let the affected vendors about like, if there's a vulnerability, then you guys need to fix that. And then vendors start to fix the vulnerability, but depending on the complexity of the program, it could be finished in a day, in an hour, but because modern software is too complex, if you change a little bit of code here, then some part of the other part might not work. So every time you make changes to the code, it runs through the thorough testing procedure. So even if you can fix the code in an hour, to actually release and deploy the patch, there are a lot of stage of the testing. So the purpose is like if we release the patch, if that broke some other regular feature, then that's another disaster. Yeah. So to not to have that kind of issue, so they thoroughly test that, and then that's why vendors need to have like an enough amount of time. So so it's not written in law or something, but in the community, we usually give 90 to 180 days, 3 to 6 months, vendors to fix the vulnerability. Yeah. So the hackers waiting for that, and then suppose the vendor fixed the vulnerability after 75 days, then they release the patch, then the hacker can publish their work for credit. Yeah, that's how it works. But there are some cases that some of the hackers just releasing their vulnerability found on Twitter wild. So there were some of the incidents like that. So there is a vulnerability report and fix CVE and update cycle. So when after finding the vulnerability, yeah, send the report to the vendor secretly. Then vendor will generate the patch and announce the CVE. Then all the users can update their vulnerability to their software to be immune to the vulnerability. That's how the market works. And then I introduced terms called the Patch Tuesday. So because this kind of thing happens a lot, so that if we do that every day, so that could be a headache for the every other people. So security engineers, researchers, they gather it all together and then try to have some of the regular schedule for that. And then not all company follows this kind of thing, but at least for the Microsoft and then some other big companies are having their own schedule for like the specific date in a month will be the releasing all the security patches. So next Patch Tuesday, you can Google it. So that's on December 13th. So don't forget to update your machines when the Windows or other software request the update and the reboot. Yeah. So that will actually fix security vulnerabilities of your laptop, desktop, and then that will make your operating systems more secure. So vulnerability disclosure is important. And then there's a way to responsibly disclose vulnerability. And then the reason why it's important is that, so we call the vulnerability that does not have patch as a 0-day vulnerability. So, and then we call 1-day vulnerability as like it used to be 0-day, but today the patch was released. So we know that there's a vulnerability for the unpatched systems, but it does not work for the updated systems. That's the 1-day vulnerability. So if you have an up-to-date system, then you will not affected by 1-day vulnerabilities at all. But the 0-day vulnerabilities, they do not have remedy. So if I just work on it and then try to find the one vulnerability, new one, then that's 0-day. If only me knows about the vulnerability, so that's the 0-day vulnerability. But yeah, and then we need to report this kind of vulnerability to the vendors to fix it to the community. Yeah, then users can update that and then they cannot affected by the vulnerabilities. Yeah. And then another important thing is like the fixing is not instant. So we need to give enough time to the vendors to fix the vulnerability. So for example, Google would like to boost this kind of the responsible disclosure and also like a patch cycle quickly, because like for some of the companies, security is not the first goal. So some of the companies, they don't care about the security and they just care about the usability and the functionality. And then the security community don't like that. And then what Google did in 2011, 12-ish was like the team is still there. So there is a team called the Google Project Zero. And then what it does is like by the name Project Zero, they are trying to find 0-day vulnerabilities. And then what they are doing is like that they are not doing that for attacking others. So they do that. And then after finding the vulnerability, and then report that to the vendor. And then give the vendor only 90 days. Otherwise, they will release the vulnerability details after 90 days, always. So it's something like blackmailing the vendor to fix the vulnerability in 3 months. So it's somewhat bad, it could be, But how I think it's like so that has been like the 10 years, I believe. Yeah, it works well. Yeah. So like at the first, like there was some of the backlash that oh, Google is hacking others, and then they're crazy. There was like some of the articles like that, but I believe that that was all good for the community. Yeah. So nowadays, like some of the general rule is like they're giving 90 to 180 days for patching. Then, how can we report vulnerabilities to vendors? So one of the ways that you could contact the vendor directly. Yeah, I have done that several times, but there nowadays is not a problem much, but that there was a problem. So the thing is, in old days, for example, before 2010, white hat hacker comes in, and then suppose I found the vulnerability of some company, then I can send an email that like that I found your vulnerability in your product, and then I know how to fix it, and then here's a potential fix, and then I don't need the money, and then just leave my internet ID as the credit. So that I literally did that in 2008, and then the reaction was it was a South Korean company, so they treated me as a criminal because the precisely accurately, yes, I hacked their computer, but what I did is like that I hacked my account, not others. Yeah, but they regard me as a criminals and then report to the law enforcement agency. But trust me, I have no record at all. Yeah, yeah. So it used to be like this, but in these days, thankfully, not like that. Yeah. And then let's think about the why companies reacted like that. Yeah. So there was a law in the US called the DMCA, Digital Millennium Copyright Act. So it's all about the copyright, about the music and then movie, video, those kind of thing. And it also includes source code and programs as a like copyrighted material. And then in the section 1201 of that one, says unlawful to circumvent technological measures to use to prevent unauthorized access to copyright works. So hacking is unauthorized access to the program, right? And then reverse engineering, unauthorized access to the intellectual property. Yeah. So those are all prohibited by law. Yeah. So in the US soil, if I purchase my own iPhone, then I do reverse engineering and hack my iPhone only. That's illegal. Yeah. Even if I did not hack the other person. Yeah. But the good thing is that, so recently, DOJ, Department of Justice of the US, they unofficially announced that they will not sue hackers by just doing reverse engineering for DMCA. So that's the good thing. But to have that kind of arrangement, there were a lot of incidents. And then one of the famous incidents was happened in the 2011. So this guy named as George Hotz, and then his internet handle is GeoHot. So he's a famous hacker. Then have you guys heard about that guy? Yeah. So he's now works for the autonomous driving company. So I use that. So that's good. Yeah. So what he did is like in 2011. I believe he was 17 years old. Yeah. So born in 1989. So yeah, maybe what is that? 22 years old or something, right? Yeah. So what he and his team did was like they hacked the PlayStation 3. So in the pristine PlayStation 3, a regular one, you cannot install other operating system. You cannot install the application arbitrarily. You need to go through the PlayStation 3 App Store and download it. But what they did is like they completely hacked the PlayStation 3, got the root permission. So you can switch the operating system. You can install Linux on it, or you can install any kind of the application. So PRC can happen. Yeah. So they developed that. And then most critically, they leaked the private key to sign something in the PlayStation 3 so that they can claim that their code is written by Sony or something like that. Yeah. And then there were a lot of like the charges so that they leaked the private key and then published it online. That's the different type of the criminal criminal activity. But actually, the U.S. government charged him about the because their group applied the reverse engineering to the PlayStation 3 software. There's a charge for that. Yeah, and then as a result, so he was settled with the permanently cannot access any kind of Sony product or something. Yeah, so this is some of the wording from his homepage, and then he say don't buy a Sony, and then some other, and then say sue me, something like that. Yeah, but I'm not teaching you to do this kind of a battle. Yeah, so the lessons are so don't do illegal stuff with the computers. So you need to know your right and then know about the law and then follow the good guidelines. So even if you have a good will, you can be punished. So for example, hacking itself could be looked as a benign if you do not do any harmful thing. But if you release the private key to public, that's a serious security breach. And also like the releasing the exploits in public without having a patch. So that they release the jailbreak tool for public so that any users can download that, run it, pirate the software. So that's the huge criminal activity. And it's not criminal, illegal activity. Yeah. So don't do the illegal stuff with computers. But I personally think that the DMCA, that act is too harsh for the security community because like the reverse engineering is prohibited, then I cannot take a look at how Apple designed their software, so I cannot analyze about their security problems. So then like so the examples about the violation of the DMCA is like the reverse engineering the device that you purchase. So even if you purchase a device, the content, the programs are not yours, so you cannot reverse engineer that. And then even if you hack your own device, your own account, not harming any others, but legally, it's illegal. Yeah. And then attack the test user account that you created. Yeah, even if you do that, not affecting to the others, that's illegal. Yeah. So I searched for the recent cases about the DMCA battle, and then there's a recent one about I haven't not played a Destiny 2 game or something, but there was a battle between some of the group that developed the cheating program for the Destiny 2, and then developer of the Destiny 2. They are doing the legal battle, and then they are claiming that the hacking group reverse engineered our program so that they violated DMCA. How do you think about that? I believe releasing the cheating program, that's the bad thing. Yeah. But the reverse engineering itself, yeah, I'm not sure. So another interesting thing is that the Bungie, that company, sued the hacking group, and then that hacking group sued Bungie again because they know our program is cheating program because they reverse engineered our cheating program. So, so that's legit, right? So that they did reverse engineer because that's why they know how it works, right? Yeah. So that they can fight like this. So I believe this is somewhat weird. Yeah. Then the important thing is then how can we protect ourselves from that kind of lawsuit when we report the vulnerability to vendors? So because in the old days there's something that treating hackers as a criminal or something. So there was a term called a coordinated vulnerability disclosure. So it's something like, as a hacker, I do not directly talk with the vendor. There is a sum of the middlemen. And then one of that kind of company is called the ZDI, Zero Day Initiative. So the name is very clear. So that they accept the 0 day. And then so as a hacker, I can submit the vulnerability to ZDI, and then it can be anonymous. So that I can use a newly created email address, and then use the onion routing to hide my IP address to send them, then they will never know about myself. And then they also guarantees that even if I reveal the identity, they will not reveal my identity without having the guarantee that the vendor will never sue the hacker. Yeah. So then what they do is like if they do all the like dealing with the vendors, and then so the ZDI or that kind of company offers full protection to the hacker. So they ask hackers to submit the zero-day vulnerability. And then, so ZDI also have like a lot of hackers that they can work with the vendors to fix the vulnerability. So some of the small vendors, they don't know how to fix the vulnerability correctly. Yeah. So in that case, they can do that for them. Yeah. And then at the end, the ZDI will ask some of the compensation from the vendor because they solved their problem, right? And then after having the compensation, they share the part of them to the hacker. Yeah. So there's no lawsuit. And then hackers can get some kind of the compensation for their own work, and then vendor fixed their vulnerability. All good. Yeah. But for this kind of model, so I've been always curious about like how the company like ZDI can earn the money. Is it something like so in a good way, they are helping fixing vulnerabilities and then notify the vendor about the vulnerability, and then they help the vulnerability so they can ask money for that. But it could be some kind of the blackmailing case. So for example, I have your product's vulnerability, and then I will let you know, please pay $1 million. Then I will pay 500K to the hacker, and then I will get the rest of them. So that kind of thing could happen. And then another thing is, so I'm not saying ZDI is doing that. So yeah, legal disclaimer. But then what I'm saying is like there could be some of the ways to do something like that. So another thing is like so this kind of company accepts the vulnerability from the hackers, and then they do have some of the period of like the embargo that they will not release the vulnerability. But there's a time period required for the vendors to fix that. So suppose that's the 3 month. But then there's a 3-month window that you can shoot this attack anywhere in the world because there's no patch. Yeah. Then if this kind of company have the bad mind, then they can sell the zero-day vulnerability to the other end. So there are a lot of the state-sponsored defense or military, they would like to purchase this kind of the exploit and shoot that. So there are 3-month window for that. And then they are actually freely gathering all the exploits from hackers. Yeah. So it's something like getting exploit from hacker as like the $100,000 and then sell that as a $3 million for the other attackers. So that could be possible. Yeah. So I'm not sure what's going on under the hood of like these kind of companies, but yeah, there are a lot of companies that do this kind of the coordinated vulnerability disclosure. So one of the report about the archive, the ZDI submitted one was like one of the hacker reported the Google Chrome logic error, safe browsing bypass. So it looks like somewhat serious, and then they do have severity score as a 6.8. So anything over than 6 is considerably risky, and then anything over 8 is super risky. Yeah, you can think of like that. And then they do have descriptions about that. And then at the end, so they announced that how it has been processed. So the vulnerability report to the vendor on this date, and then around the 6th month, after 6 months, so that has been patched, and then this kind of the public release has happened. Yeah. So that they give like the enough of time to the vendors to fix them, and then credit is anonymous. Yeah, maybe the hackers are not interested in like taking the credit with their handle, or like they are worrying about like them not become like the hacker, like who report the vulnerability like that. It could be, or they just interested in like the bounty money. Yeah, after ZDI pays out for that. Yeah, and then ZDI, yeah, they publicly accepts vulnerabilities and then do report to the vendors. But they also offers a fun hacking competition, targets the real programs. So what they are doing is that this competition pwn to own. So it's something like attack the machine and then like get some cash. Yeah, that kind of term. And then so it is like it is a conference and competition, and then it is always happening in Vancouver, Canada, and around March or April. And then they announce a target a year ahead. So it's something like that to the hackers, giving 1 year of time frame, and then hackers are working hard for like the finding zero-day vulnerabilities. And on that day, they come in and then they demonstrate their hacking to the latest version of the software. Yeah. So, and then targets are like the virtual machine monitors, web browsers, any kind of operating systems, or cell phone, iOS, Android, and those kind of thing. Yeah, these are all like the targeted. And then, so you can see some of the payouts. So it says like the 0.27. So if you successfully exploit the one of the target, you will get 4 points. And then there is some of the additional extra credit if you do some more of a hack on top of it. So you can regard the 6 points could be like the one hack or something. So in this case, this first place guy, yeah, this one hacked like around the 4 to 5 systems, and then like take away like this amount of cash. Yeah. So there's a fun hacking competition, but the good thing is like in this event, ZDI person will be there. And then if the target is Google Chrome, and then Google Chrome security engineer will be there. And then the hacker can demonstrate that. And then the vendors can immediately work on the fixing the vulnerability. So all transparent, but the details are kept a secret, yeah, until the patch is announced. Yeah. And then not just for the coordinated vulnerability disclosure, thanks to the community work. So nowadays, many software vendors do not regard hackers, white hat hackers, as like criminals. So instead, they are actually crowdsourced for their security purpose. So what they are doing is like they are offering a bug bounty program. So I pasted several links so that you can go there. Then there's a description about what is the target, and then what is the legitimate thing, and then what are the rules that hackers should follow. So that they announced that they have a written statement that you should never hack other users, you should never hack the core systems, and you should never leak the data, delete the data, those kind of thing. But what you can do is like you can hack your account, test account that you created, something like that. And then not just for the Meta, Google, Apple, those kind of the big companies, even for Discord, they offer the bug bounty. And then this is the image that I got the bug bounty in 2013. I found a little cross-site scripting vulnerability from Facebook, and then they paid $500. But if the same vulnerability happened in today, then that would be the 40 to 50K US dollars. Yeah, the reason is like at that time there was too many cross-site scripting vulnerabilities, so that was not the rare. But then nowadays we have a lot of like a syntax checker kind of thing. So we try to eliminate the cross-site scripting, but yeah. So now it's rare, so it's quite hard to find, and then the bounty gets expensive. And then the bounties for the public, this kind of the bug bounty ranges from it could be just sending gift for $50, or it could be 250K. So I believe right now, if you hack iPhone, get a root permission, and then get the kernel execution, then you can get like 250,000 US dollars from Apple. Yeah. And then not from the vendor directly, because not all vendors can run the bug bounty program. There is a company called HackerOne, and then that company runs a bug bounty for public. So think about some of the small companies, they don't have the resource to run the bug bounty, but what they can do is they just outsource vulnerability report and then like do that kind of thing with the HackerOne. So you can think HackerOne as more like a ZDI kind of thing, but their level of the coordination is somewhat weak. So the ZDI, what they do is like they completely make the submitters anonymous, and then they contact the vendor directly. But in HackerOne, if I report the vulnerability to HackerOne, then those guys actually matching myself to the engineers at the vendor, and then we closely work together to fix the vulnerability. Yeah. So it's a good experience because we can learn more about like what's the internals, and then like sometimes you found the vulnerability and then cannot understand why that kind of mistake has happened, but you can learn more about by having a chat with the engineers. Yeah, I believe like that's under NDA, but sometimes like we can listen to like those kind of the valuable information. Yeah. Any questions about the bug bounty or this kind of the vulnerability rewarding or coordinated vulnerability disclosure? Then one message from Zoom side is like the one student, Hassan, mentioned that the Discord gives a hacker a bug founder badge on the account if you found the bug and then submit that. Yeah. So please try to get it and then get a badge on it. And then next is about the vulnerability markets. So the previous part are like the white hat good markets, but I'm not saying vulnerability markets are bad, but I will let you guys determine about that. And then there's a company called Zerodium. And then if you search it and then go there, then they say we pay big bounties. Yeah. And then what they say is like the leading exploit acquisition platform for advanced zero-day research and then cyber security capabilities. And then I'm not sure how you read these lines, and then how I read these lines. Like I want to purchase a lot of exploits a lot, and then that would be helpful for all the offensive hackers. And then, yeah, something like that. And then they do have a payout table, and then this is the table. So I previously told you that if you hack iPhone and then report that to Apple directly, then the maximum bounty is 250,000 US dollar. But if you succeed on exploiting Android or iPhone, 0-click. So the 0-click here means that the user need to do nothing. And then user even don't know hack has happened. Yeah. Then let me explain the 0-click attack first. So suppose an attacker discovered the 0-click vulnerability in iMessage. Then how it works is that if I know one of yours iMessage account, then I will send the message. So similar to the buffer overflow exploit, the message itself contains my attack payload. And then if I send the message, iPhone will parse the message and then try to get the summary of it to show the push message and then display the entire message onto the iMessage window. But before doing that, if we can hack iMessage before sending the push message and then print the message, we can change the control flow of the program to somewhere else. Then user will never see that the message was received. And then user will never know their phone was hacked. And then after that, the attacker can make the attack persistent by breaking the application sandbox, attacking the kernel, and then change the file system. So how it works is like after you turn off and then turn on iPhone again, then the hacker makes the booting process hacks the system again, yeah, to make it as like the status about like the attacker's program always running, yeah, as a background or something, yeah. And then if we succeed on that kind of the 0-click attack, they pay 2.5 million or 2 million or if it's just an iMessage or WhatsApp or SMS attack, yeah, they are 1 million and then more than that. Yeah. Then let's think about their business model and then what are their customers. Yeah. So the first question could be who will pay that much amount of money, $2 million, $2.5 million for the zero-click exploit. Vendors, definitely not. They do have their own bug bounty program. And then vendors, definitely, they do not need zero-click exploit. They just need crash. Yeah. So the attackers don't need to develop the full exploits for that. And then next question could be, then who needs zero-click exploits? Yeah. So that's definitely someone who wants to secretly peeping on the user's data of the affected products or stealing some of the data or something like that. Yeah. So I want to introduce that because software attacks are serious, that could be used as a cyber weapon these days. So to understand this kind of thing, let's assume a fake scenario. Suppose you are a president of the UCE, so some of the different name country, and then you will have a huge deal with some of the oil company tomorrow morning, but you would like to know what is the minimum price that they will accept the deal. If you know that, then you can get the minimum amount, then that's good for you. Yeah. But in 1970s, when the Richard Nixon was there, and then like many other people, what they did is like they tried to install this kind of the eavesdrop bugs on the hotel room, or I'm not sure you have seen this kind of movie, Mission Impossible, the original one. Yeah. So what Tom Cruise is doing right now is like they need to steal some of the documents in some hidden in some of the building. So they need to send the secret special agent to actually steal that. Yeah. So that's the old day spying and then like intelligence. But nowadays, how it works is something like, suppose you know the iMessage of the ID of the executive. So that's quite fair because like we talks over email, and then maybe I can ask like, I want to text you, what's your iMessage handle? So that's not that weird at all. Then after knowing that, I can send the zero-click exploit and then leak all the messages that they have. Then if they internally talk to their president about like $3 billion US, the minimum amount, then yeah, done deal. But suppose the data is not in the phone, then what the attacker can do is, so prepare a PDF document. But that's after finding a vulnerability in the PDF reader, and then crypt your PDF document. It's look like a regular contract, but the inside of there's a hidden payload. And then whenever you open the PDF document, that will hack the program and automatically runs the attacker's program. Yeah. So in that case, send the PDF, they'll open it, their computer got hacked, so leak the deal information. That's how it works. Yeah. So I'm not sure you have identified that some of the weird email address send a message to you attached with the PDF. So something like here's your Black Friday invoice and then $500 or something with your, like it's weird with some of the credit card number or something. Then many of the users just open it. Yeah. And then if you have an old version of the PDF reader, that means like you got hacked. Yeah. So some of the ransomwares are spreading with that kind of method. So I never opened the PDF from like someone that I don't know. Yeah. And then the more sophisticated attack could be, so as an attacker, we can send the PDF to hack the laptop. We can send iMessage to phone. And then if the secret documents is stored into their company's database, then how we can do is we hack both of them, and then logging the keystroke from the laptop, we can steal the password. And then if the corporate login requires a two-factor authentication, we can do that by hacking their phone. Yeah. So the two-factor authentication doesn't matter at all. And then after connecting to the VPN, so find another software running here, and then shoot the vulnerability, hack the server machine, yeah, and profit. So this actually works, and then this kind of thing is not that sophisticated at all for the state-sponsored attackers. So that's why there is a market about like the state-sponsored the military or some of the intelligence or secret agencies. They would like to purchase a lot of variability to shoot each by each to achieve their own goal. So the implication is that the software attacks are so powerful in these days because most of things are connected to the internet. So regardless of the geolocation, we can hack the machine in China, India, Korea from the US, then vice versa. Yeah. And then there are many small devices such as like a smartphone, smartwatch. Then we do have smart speakers, or even for the power outlets has internet connections in these days. So these are all can hack. So software attacks are powerful. And then I personally have a belief that all systems can be hacked because we human write the program. Yeah. So if the program is written by machine with the every proof that it will never have the vulnerability, then it'll be secure. Yeah. But that they cannot come because Alan Turing proved that. So I believe I secured my job. Yeah, it will be never-ending problem. Yeah, but yeah, that's my belief, and then that's why my domain name is Unexploitable Systems. I would like to build it, but yeah, I think that's impossible. But yeah, I want to have that. Yeah. So how I think is like anything runs software or hardware, yeah, digital systems, they can all be hacked. Yeah. So think like anything connected to the internet. Yeah. That means attackers can remotely control over that, take control over that. Yeah. And then anything receives input without physical touch. What that means is that have you heard about the case that like the smart speakers, Amazon Alexa or other smart speakers are reacting to the speech from television? Yeah. So in the TV drama, like some people just speak it, something like that, and then, oh, let's get some pizza. Then like the Alexa can say like, what kind of pizza do you like? And that actually happens. Yeah. Right. So the problem was like that their smart speakers accept any kind of voice, and then they do not check liveness, and they cannot distinguish whether that's from speaker or human vocal or something. Yeah, so that's the problem. So don't trust that kind of input, so that could go wrong. And then like that, I believe the only thing that we can trust. So relatively trust. So relatively good things are like something physical. Yeah. So even if it is physical, it is linked with the digital hardware that could be hacked. So that's dangerous. So what I like is this kind of the simple one. So in old days, all the laptops has this kind of switch. You can turn on, off the Wi-Fi. And then if you turn off, there's no software where you can turn back on because it's a physical switch that disconnects some of the power line to the Wi-Fi device. And then also for this kind of the camera blocker. Yeah, I really like this kind of thing. Yeah. So for Apple device, so you will see that the green light emitting when the camera is operating. And then that has the physical wire to power to the camera and power to the, what is that? The light. So that whenever the camera is active, then it is guaranteed that that green light will be there. But many of the other laptops does not have that. So in that case, users don't know whether the camera is active or not. So in that case, we definitely need this kind of the physical security step. Yeah. And then, so anything runs with the software can easily be hacked remotely. And then we are living in the era of the ubiquitous and pervasive computing. So I'm not sure like how old you were when the word of the ubiquitous computing comes in. And then when I entered college in 2003, and then like at that time, the biggest keyword was not AI, not cloud, not deep learning. The biggest keyword was ubiquitous computing. And then I believe like ubiquitous computing has not come in that era. And then it came around 2017 with the rise of IoT. Yeah, that's what I believe. But we are living in that area. So computers are everywhere. So smartphone, smartwatch, smart speaker, smart power outlet, they all have the access to the internet. And then they also have a lot of sensors. So for smartwatch and smartphone, and maybe smartwatch, then if you hack that, you can know that when the user sleeps by monitoring the heart rate and then breathe or that kind of thing. Yeah. And then you can also monitor where the user is. So it's naturally a tracking device. Yeah. So if the device got hacked, that it could turn into that kind of the surveillance device. So that's why I'm telling that in 1970s, 80s, yeah, 90s, we do need a special agent to follow you to like the peeping on like what you are doing. But in these days, we don't have to do that. Just shoot the exploit. That's it. And then we can turn all these kind of device as a surveillance device at all easily. So let me bring some of the possible, some more possible attack scenarios. So I just introduced all about the software attack, but that software attack can be connected to some physical or hardware-ish medium. So one of the things that I would like to introduce is so-called dolphin attack. And then try to think about the scenario that, so maybe suppose I, as a hacker, yeah, suppose I hacked one of your smartphone. And then if I record your voice, always recording your voice or something, so it's naturally the eavesdrop a bug. And then suppose when user gets to their home, yeah, so that by looking at the GPS location, yeah, we can identify that's home. And then what we can do is we can send Amazon Alexa for ultrasonic sound for something like order 100 copies of the Youngjin's program. Yeah, make him rich, something like that. And then that's possible because one of the paper called the dolphin attack, they say this is the reaction of the Amazon's microphone to accept the audio based on the frequency range. And then interesting thing here is that the humans can only hear in range frequency of like a 20 to 20,000. But the speakers are reacting to the frequencies over the 20,000. So if I play the Alexa order 100 copies in like the 25K hertz, nobody here can listen to it. Yeah, yeah. So that's actually secretly launching the attack. Maybe if we launch the attack, then Alexa will ask back, all right, here's something, and then confirm that. Yeah, then if they ask that, like the users would immediately know about that. Yeah, but at least for the smart speakers or that kind of the devices that accepts some of the human voice. Yeah, if they did not filter out inaudible frequency range, then they could be affected by this kind of attack. And then another possible scenario is that I told you that I like physical stuff because remotely they cannot touch it. But think about right now I have like the robot vacuum, but that does not look like this. But some of the technology companies would like to build a robots that like the sorting all the clothes and then the washing dishes or something like that. So in that case, it could look like this one. Then if I hack that one, then I can move that one to turn on the Wi-Fi switch or slide off the camera. So that's all possible. And then if I can hack drone, then it has more mobility. And then also if I can hack autonomous driving car or something, so there are a lot of capabilities that the cyber attack can result in. Yeah. And then I'm not promoting you guys to do launching this kind of attack. So that I'm letting you know about all these things are there. And then we need to work hard to prevent this. Yeah. So let's do the summary of what we learned today. So software vulnerabilities are there. It's hard to catch, but there is an automatic tool that we can utilize. So by just adding some of the compiler options and not ignoring on the compiler warning messages, so we can avoid some of the risks. And then we have learned about several ways to responsibly disclose your vulnerability. So one of the ways, like using the coordinated vulnerability disclosure, something like contacting to the company like ZDI or HackerOne, or nowadays the mindset of the most of the software companies they are welcoming white hat hackers for finding their problems. So if so, then like we can directly contact to the vendors through like a bug bounty programs, or like directly talk to security engineers in there. And then the most important thing is like the patching requires a significant amount of time. So the de facto standard is like giving more than 90 days to patch the vulnerability to the vendors. Yeah. And then we are living in the ubiquitous computing era. So many things are connected to the internet. So when you are assessing the risk, then the worst case scenario, to get the worst case scenario, you can assume that all of your software can get hacked. And then think about what can happen by linking all the stuff. Yeah, that's the thing that could happen as a state-sponsored cyber attack. So today we learned about the not technical, but more about like how the entire community and then the procedure works. Yeah, and then on Thursday, as the last lecture, we'll learn more about the malware and then the real weapons, about like how they have been used in the wild, and then what are the efforts of the security researchers to counter against those kind of attacks. And we will learn about that. And then this is the part of the today. And then feel free to ask any question related to this topic or any other, or related to the assignments. Yeah. All questions are welcomed. Yeah. All right, let's finish today's lecture here, and then I will take questions. Yeah. So yeah, don't submit write-ups. Yeah. Yeah, don't submit write-ups. It's okay. Yeah. Yeah. I realize that some of the challenges and like the recently released ones, these are too simple to write ups. That's why.
So we're still doing write-ups for all the crypto challenges?
Yes. Yeah. The reason why I asked for the write-up for the crypto is that, so I know that like if you just follow the slide, you can easily get the answer. But what I want to have is like I know you are all honest. Yeah, you try to understand the thing, but there's a case that you don't understand something, but they got the flag. But I don't want that case happens. So if you get the flag, you should know what happened, and then details of that, and then by writing the write-up, and then it could be more clear. That's why. And then for the others the others are too simple. Oh, another thing is like I will create a grade page on our scoring system, so that you will see that how much points you have earned, and then I will also convert that as a maximum 100 as a percentage score, and then I will also post the grading brackets for that. Yeah. So before Thursday, you can see the grade menu on the scoring server, and then I will announce that when it's ready.